Hello, everybody. Welcome to this session of GSMA IoT WebTalk, the Power Partnership, the clear skies ahead for mobile-enabled aviation. So this session is being divided in different areas. We will have a brief introductions of the organization GSMA, GUTMA, and also what is the ACJA. Then we will have each work task leader providing a quick overview of what they've done so far in this year. So with the achievement of 1 year of working with the ACJA. And then we will have a panel discussion where we will also be joined by the board member of the ACJA. And altogether, we will answer your difficult questions. So with no further ado, I will go to the next slide and give you a brief introduction of what is GSMA. I hope that the majority of the people that are online already has an idea of what GSMA, but just to give you a very brief introduction, GSMA is a non-profit organization which represents the mobile industry. Our members are the mobile operator, and we have more than 750 members, and also the stakeholders in the ecosystems, which are more than 400 other organizations. One important part that I want to point out here is that we have a very wide number of expertise from the industry. You can say that we connect more than 23,000 people in the industry. So we are the organization that has the broadest informations and knowledge on the industry itself. And I want to stop here with the introduction of GSMA. I want to give the floor now to Paweł Trumonsky, which is representing the Global UTM Association. So, Paweł, the floor to you to introduce GUTMA.
Thank you very much, Barbara. Few words about the GUTMA. GUTMA, it is a global UTM association, the same as GSMA. It is non-profit association that gathers different and the various stakeholders from the aviation and non-aviation community, and our primary goal is to promote harmonized skies and promote UTM solution globally. And I would like to, using this webinar, say thank you to GSMA and all leaders that are driving this cooperation, because thanks to that, as an association, we are growing, we are expanding, and we are learning how to use a knowledge of our members and partnership with our co-partners in the association to be a better association and to influence on the market. And we encourage you to learn and familiarize with the GUTMA and join, because we hope that we will be able to not only support connectivity area, but also others. Within this short introduction, I would like to pass the ball to Chris Kusera, ACJA technical lead. Thank you.
So my name is Chris. I'm with OneSky. OneSky is a company that is focused on aerospace software and developing UTM solutions. I'm the co-founder and in charge of partnerships for the company. I also serve as the technical lead for the ACJA, and I'd like to introduce the ACJA to those that aren't familiar. So the ACJA is the Aerial Connectivity Joint Activity, and the concept of it started many years ago in GUTMA and with GSMA support. Early on, we called it the Connected Skies. We had these events where we would talk about the use of cellular to connect the drone community. And so the issue is that the air traffic management community is supporting things like VHF and UHF for communications, which doesn't really support our needs from the drone industry. So we need new infrastructure. We need to be looking at things like the cellular infrastructure to support concepts like flying beyond visual line of sight, where point-to-point radios aren't effective. To do that, we need to start looking at standards, and there's various standards bodies that are helping, like through GPP on the cellular side, and then ASTM concepts, as well as other bodies like RTCA. So ACJA was founded really to look at the new infrastructure and try to solve some of these problems of using cellular, which is one of the communications is one of the biggest roadblocks to moving beyond visual line of sight forward in the community. So this slide talks about what ACJA is doing. The stakeholders are on the left and right, where we have the aviation community and the network community on the right. So we're bringing together the manufacturers, people building drones and putting on modems on board the drones, how those modems would need to operate, maybe operate differently in the future to reduce things like interference, and how we need to authorize those systems in organizations like the FAA or the FCC. In the middle, you'll see different work tasks that we're working on. We'll hear from the work task leads today, and we're working on new terms of reference to move ACJA forward. So with that, I will pass it over to Stefano and enjoy the presentation. Thank you.
Thank you, Chris. My name is Stefano Facin. I'm a Director of Technical Standards with Qualcomm, and my focus has been to develop the ecosystem for UAVs and urban air mobility, promoting solutions that will leverage cellular connectivity in the ecosystem, both considering both 4G and 5G. Now, Working Task 1 in particular focuses on the connectivity framework for UAVs and UAM based on the 3GPP system. And our goal in Working Task 1 is to create a bridge between the work on UAV and UAM in the aviation industry, including regulations, various standards, Chris mentioned some of them, with the work that is ongoing in 3GPP. In particular, we aim at reusing and leveraging all the 3GPP tools that are available for communications for this vertical, and bring new requirements and solutions to 3GPP where we see the need for developing new mechanisms. So we have a complex framework in terms of UAV connectivity in the 3GPP ecosystem, and we try to capture somehow in this picture, and where you can see we have a variety of UAVs and UAMs and a variety of UAV controllers that are being considered, where we have controllers that may be using just dedicated radio frequency directly to the UAV, or maybe controllers that are themselves 3GPP devices, or the more generic model where the controller is an entity on the internet that communicates via internet for command and control with the UAVs. In this system, we are using cellular connectivity for command and control, identification, and for UAV to UAV communication. Now, there are several focus areas that I try to highlight in yellow here for the Work Task 1 that are essential to guarantee the development of complete solutions for UAV and UAVs. So one of them is the support of C2 connectivity, so command and control connectivity over 4G and 5G links, and support of remote identification over cellular technologies. That is definitely one of the biggest building blocks. Interfacing with the UTM infrastructure at large is also very important to enable open interfaces and exposure of services and information by the mobile operators to the infrastructure. So this includes access to additional services provided by the 3GPP system for the UAV and UAM mobile devices, such as location, tracking, monitoring of connectivity, coverage information with respect to the definition of flight plans, quality of experience for UAVs, and so on. And Thomas later will mention some of these aspects more in detail. And for this interfacing, we're working closely with other working tasks, so working tasks 2 and 4 in particularly, on KPIs and SLA requirements between the UTM and the MNOs to make sure that these are supported and implemented in 3GPP solution. The radio is, of course, a very important aspect that here we highlighted the spectrum and beamforming. So we are having discussions on that relate to the regulators' decisions about what spectrum to use for UAVs, and this is both for UAV to ground, so the traditional cellular connectivity, but also for UAV to UAV and other devices. Now, so far, we have not been addressing directly radio aspects in terms of defining radio solution, but our aim is mostly to influence the work that is already ongoing in 3GPP and that will be done in the future in 3GPP, such as the definition of NR aerial features. And we are entertaining discussions, of course, related to the use of radio technologies and details that need to be defined outside 3GPP for this. Security is a big building block, and this includes both the authorization of aerial vehicles by the UTM for operations of a 3GPP system. It includes network remote ID security and broadcast remote ID security, and potentially the area of detecting misbehaving UAVs and UAVs that deviate from acceptable operations. The last building block that we're focusing on is UAV to UAV and UAV to ground connectivity using cellular technologies, where the aim is, of course, to use PC5 and Sidelink to enable both remote identification and a detect and avoid solution over cellular technologies. Our deliverables come in the form of white papers, definition of solution, and input to 3GPP in the form of liaison statement or direct company contribution based on the work in ACJA, both of the definition of work task in 3GPP and the definition of technical solutions. So that's an overview of working task 1, and with that, I'd like to introduce Jerry Libunau, leader of work task 3.
Thank you, Stefano. So my name is Jerry Libunau, and I'm in Verizon's Global Network Technology with a focus on standards and industry. So to the question of how cellular can enable BVLOS or the beyond visual line of sight operations, let's first recognize that 4G LTE is widely deployed around the world today, and support of aerial service across interconnected LTE networks, at the same time providing seamless roaming, will enable secure VBLOS drone operations. Now, the important first step to this is the definition of cellular network connectivity profiles for aerial service, and this is the mission of Work Task 3. Work Task 3 delivered an LTE aerial profile, which is also available on the public websites of GSMA as well as GSMA. The profile identifies a mandatory set of features in 3GPP, which an aerial UE integrated with a drone and the network are required to implement an interoperable aerial service over the LTE radio access. Now, adoption of these features are considered essential not only in launching interoperable services, but also reducing interference caused by the aerial UEs. And this is what actually will help scale the network as more commercial and personal use of drones take place, at the same time ensuring the overall goal of its safe integration in the national airspace. Now, the Work Task 3 group is currently dormant pending the completion of standards in both the 3GPP in support of NR, as well as the ongoing work that Boris will expand a bit later on LTE MOPS, or minimum operational performance requirements in RTCA and EuroK as well. And lastly, the LTE aerial work from ACJA has now been transferred to GSMA, and work is ongoing to develop and publish guidelines for LTE UNI profile, as well as related roaming and network interconnection support of aerial services. So at this time, I'm going to hand it to Thomas Neubauer.
Thank you very much, Jerry. Welcome to Work Task 2 overview. First of all, my name is Thomas Neubauer. I work for TIOCO as VP of Innovations. During my day shift, I work on solutions like airborne RF. On the night shift, I actually I'm honored to lead work task 2 of ACJA. And before I go into the details of what we are doing, what we have achieved, and what we are aiming for, I would like to emphasize on why we are actually doing this. So one of the key objectives in order to scale beyond visual line of sight drone operations is to establish sufficient connectivity. And efficient and sufficient connectivity is absolutely crucial for the remote identification of drones, but also for command and control. Just consider a drone that is not able to communicate. It may be deemed a non-cooperative drone, and that's something that we clearly have to avoid in an integrated airspace. So as a consequence of that, it is important and mandatory for drone operations, for the aviation management and drone management systems to understand where such a connectivity that is sufficient for the BVLOS operation actually exists. And for that, they need to consider data from the communication service providers, and in particular here from the mobile networks. But here's the challenge. Historically, aviation and mobile network operations did have nothing in common. They have no overlap. There was no data exchange. So this is why at ACJA, Work Task 2, we have been looking into how can we find a harmonized way, globally harmonized, to exchange the data that is needed for a UTM system, for a drone operation, to identify where it is actually safe to operate drones beyond visual line of sight. And that is needed for pre-flight, like for flight planning, but also for in-flight and post-flight data exchange to understand where that information is there, and also in case something happens in the network, something changes, that the aviation systems can be notified. So with that objective and with that purpose, we are thrilled to have in Work Task 2 a number of mobile network operators around the world, actually from 5 different continents, participating in this action, as well as a wide range of UTM, UAV, aviation stakeholders who have been working together over the last 10 months to bring together as a first achievement a globally harmonized definition on how that data can be exchanged. And that is number one, for a 3-dimensional connectivity. So where in space, where in the airspace do you have sufficient connectivity, that data, but also another category of data that is existing at mobile network operators and of very high value to the aviation and unmanned drone operation system is about the ground risk. So where people are at the given point in time. So this achievement, this network coverage service definition has been the deliverable of the first part of this work, and it can be downloaded. When you get these slides, you will have directly a link to download this specification. But the real success of this definition actually comes with the implementation in live systems. And with that, I'm extremely pleased to say that by today, we already have either already implemented or in the process of implementation real cases on 3 continents where the network coverage service defined by ACJA is actually being implemented. So if you are on the call, a mobile network operator, or from the aviation side, a data consumer of such information, and you would like to figure out how that can be utilized and how that is actually done in real world cases already, You can reach out to us as ACJA or directly reach out to me. I have sent here also my LinkedIn connections, and I will be more than happy to connect you with the other stakeholders here in the community. Most of all, of course, we would love to have you participate in ACJA moving forward, because we have some very, very interesting questions that we're working on right now. The first one is, as soon as we can exchange data, the next question is, what would be appropriate thresholds? What would be appropriate requirements that make the connectivity for a service profile, as Jerry defined just before, what would make that good enough? That is important for mobile network operators to answer, where can I provide such service? And it is also important from the aviation side to understand what is needed and where can specific services actually be provided on cellular networks. So we're working on that. And the second point is, aviation has some very important requirements with regard to monitoring and logging of information, so that you can understand if there is a symptom, a problem, how to find out the root cause and to eliminate it, so that the safety is actually assured. This is also what we are doing, where we are finding harmonized formats on global scale in terms of what needs to be measured by the UAV and how does that have to be correlated with the network data, so that the safety aspects from the aviation side can be fulfilled. So there's this intersection of UAVs, beyond visual line side drone operations, and mobile networks. That is what we're aiming for. You're absolutely invited, and please join ACJA if that is of interest to you. And a very important topic about what are these requirements is actually handled by my colleague Boris Resnick in Work Task 4, where I would like to hand over now.
Thank you, Thomas, and good morning, good day to everyone. So I'm Boris Resnick, Deputy Technical Director in GLONASS Union, Moscow-based non-for-profit partnership built tasks to promote navigation and communication technologies, and ACJA Work Task 4 lead. So we know that for aviation, any adoption and integration of a new technology or a service requires industrial standards to be developed, and that is pretty vital for aviation. Standards ensure both successful development and certification, as well as interoperability, which is also very important. So main aviation standard development organizations, or SDOs, include EUROCAE from European side and ATCA from the North American side. And there are activities within that organizations which address command and control connectivity for unmanned systems, including that based on cellular technologies. And these are Work Task 105 in EUROCAE and Special Committee 228 from RTC side. So the primary task of Work Task 4 is to interface with that standard development organizations and provide them the expertise needed from other work tasks of ACJ and in general from telco community, and to translate aviation requirements to cellular language. The Work Task 4 has drafted the minimum operation performance specification for UAS communications by 4G LTE mobile network to facilitate quick start of these activities within those SDOs. So, and the work tasks will continue to work along with them and in close coordination with them, together with other work tasks in ACJ as well, and going with that specification through both operational and technical definitions, including safety and performance assessment process, which is again very important for aviation to adopt any new technology and to make sure that flight safety is not jeopardized by using new technologies. And aviation standard development community will focus now on command and control communications, while Work Task 4 will continue to work to define requirements between air vehicles and UTM, UAS traffic management systems. So upcoming work tasks for deliverables now are the specification, the MOPs, defining use cases and technical requirements for C2 connectivity. And the second deliverable, like independent for the time being from aviation community, would be architecture and use cases for UTM connectivity in the form of a white paper. And as a conclusion, I must say that the very recent developments in SDO give us hope that 5G will come into the scope together with 4G much sooner than we would expect, and that will help us to make sure that the upcoming standards will be up to date and correlate with the development and deployment of 5G technologies. And that's it for WalkTalks 4, and I hand over back to Barbara.
Thank you everybody for the short presentation. So now we would like to have a panel discussion. So all the speakers that you already heard will join. In addition, we will also have everybody from the board of ACJA. So maybe I want to start with the first question to you, Chris, as a technical lead of the ACJA. So we are seeing that the ACJA has done and defined quite a good work so far to define the technology and integration for the US to take the advantage of the cellular infrastructure. Can you give us some idea what it is driving so far the timeline perspective, and what do we envision that the US needs approval to fly with cellular?
Sure, thanks for the question. So the drivers for communication over LTE or cellular, it comes from flying beyond visual line of sight first and foremost, I think, because existing unlicensed spectrum, we can do point-to-point flights with visual line of sight drone applications. But to move beyond line of sight, we need a new system. And so systems that are in place are things like satellite communications or cellular. And cellular is very robust throughout the world. And there's a lot of users of cellular paying for those types of systems to be robust. So it just makes sense to be able to use that for the drone community. So the first driver being, being able to fly beyond visual line of sight. So if we look at that, we're thinking about having certified drones that can fly in urban areas over people where they're deemed by the regulators to be safe to fly. So I think the first thing we're looking at is when will these drones be certified to fly? When they do get certified, they're going to be looking for C2 and detect and avoid solutions. And some detect and avoid solutions are based on the command and control link to be able to send surveillance information down and do detect and avoid in the UTM system. So I think we're looking in the US at getting some small UAS certified within the next 12 to 24 months, I guess. But it doesn't suggest that LTE isn't useful now. There are plenty of people using LTE. They're using it in trials. And I think that the problems that we're faced here in ACJA is how do you make that sustainable? How do you make it scalable? So we might need to make changes in the way that the modems operate on the aircraft with different chipsets, and how the operators operate their networks. That's being handled in things called the LTE aerial profile, which we can talk about more. But I think finally the business case, right? So there's a lot of users of the network that are ground, and the new entrants, there's not that many compared to the existing users. And we have to see, we have to believe in the business case of drones to finally move beyond that chicken egg problem, right? Where if you build it, they'll come. We need to just understand that this market is there. If we start building it, then we can support these new use cases and attract more business to the mobile network operators. So I think that those are the points I wanted to cover.
Thank you, Chris. So then I have another question, which is for Eric. Eric, after I give the question, if you can also introduce briefly yourself, since you're new to the audience. So when do you anticipate that the market momentum for cellular connected drones is actually starting, or it's already started?
I'm Eric Ringer. I'm one of the co-founders of Skyward, a Verizon company, and I'm also our chief of staff. Skyward has been a part of Verizon since early 2017, and then in the drone industry since 2012. I've been in the aviation industry, got my start about 10 years ago, a little over 10 years ago, working for NASA and Sikorsky contractors. So love aviation. Aviation is my passion, and I'm about 4 years into my telecommunications career. So these things coming together, aviation and cellular, really fit my area of interest quite well, and I'm really pleased to be doing the work that I am with ACJA on the board here. For beyond visual line of sight, or for, I guess, cellular communications in general, as Chris said, beyond visual line of sight's the primary impetus for adoption of cellular. We don't really need cellular until you're going beyond where the point-to-point solutions make sense. So when we look at market momentum for cellular communications, we look at what are the things that lead to beyond visual line of sight. So those are some of the things that Chris covered. As far as applications go, generally we think of drones being used for three main things: to collect data, to deliver packages, or to move people. Now, obviously, none of us are hopping in a drone today and taking an air taxi somewhere yet, but those are the three big categories. Collecting data is the one that's in most use today. Delivering packages is getting going and has a lot of promise for return on investment in the future once we can actually leverage beyond visual line of sight. And then in the future, air taxis, moving people. So if we look at market momentum, we look at how are drones being used today and how can they go farther, and when or where is cellular communication going to be used for them going farther. To understand that a little bit better, we look at the applications where air risk and ground risk can be mitigated well. So Chris talked a little bit about certification. So drones being reliable enough that they can fly over people. That's one way. Being able to fly over people is one way. Certification is one way to mitigate ground risk. Another way is just to make sure that there are no people down there to begin with. And so that leads to use cases where there's drone use, maybe remote drone use in a controlled perimeter type of setting. So those are things like closed infrastructure, like Verizon was able to operate a drone remotely to inspect our telecommunications infrastructure during a wildfire in Washington last September. We were able to do that because we had controlled access to that facility. So those are places where beyond visual line of sight can make a little bit more progress. So that infrastructure inspection. Another one would be places where we can mitigate air risk a little bit better. And we see evidence of that, at least in the US, through close proximity or tactical beyond visual line of sight waivers, where the drone's not rising above the building level. And if it's not above the building level, then it's a pretty good chance that there's not going to be other aircraft in that area. So we see some momentum there. So those are good indications of places where the drone is going to be remotely operated, and networked communication is helpful in doing that. And as we get more and more into the certification that's needed for scale, that's where we'll see more market momentum in the cellular side of things. Also in drone delivery, that's another place where cellular is big, because drone delivery is not economically viable unless you can fly either farther distances or at least separate the operator from having to be personally responsible for this one drone that they can see with their eyes. And the more progress that we can make with regulators on drone delivery, the more market momentum we'll see with cellular communications as well. And we see signs of that improving, making more and more progress over the next 2 to 3 years.
Thank you for that. So then maybe I want to go to have a question to Thomas Neubauer. So Thomas, for you, we're talking about the need of having the connectivity throughout all the flights. So how do you see if there is no cellular connectivity? what are the thoughts on BVLOS communication where there is no terrestrial cellular connectivity?
Right. Just to check if you can hear me well. Great. So yeah, the key point is that there are several possibilities right now that are in test and under investigation. Number one, there are some redundancy requirements, obviously, that we have from the aviation side. So that go beyond where cellular is available, and that means you can have some narrow band capabilities, even still based on 3GPP standards. But there's also some possibilities that are currently looked at from a satellite link. So there are some solutions coming up that have hybrid cellular and SATCOM fallback. That is a possibility, particularly in areas where cellular is just not built out. But the majority for the connectivity we expect to have from cellular, because it has so many more advantages against other technologies that are out there. We will see a number of deployments going ahead. So there will be some field implementations that we are also within ACJA be discussing. So if there's anybody particularly interested, reach out to us. We will discuss them also in Work Task 2 of ACJA.
Thank you for that, Thomas. Maybe now I go to a question of Stefano. Is how do you see in the future or already now to have a better integration between the aviation and the 3GPP community, so the traditional SDOs and telco community?
Thank you, Barbara. Yes, it's actually a very interesting subject. So one thing, so from the 3GPP community, this aviation ecosystem is, of course, being seen as one of the various verticals that we use 3GPP systems. And for a better integration, something that is going to be really important is, of course, to hear more input from the aviation community. So ACJA, one of the goals that we have is exactly to collect more feedback and more input and requirements from the aviation community so that we can take this input and ensure that 3GPP systems are designed and deployed in such a way that they satisfy the needs of the aviation community. And I think what is very important is to increase the dialogue between the two communities, and ACJA is actually being tasked exactly to do that. It's a perfect venue because we understand that not all the relevant members of the aviation community can be active into 3GPP activities and vice versa. But I would say that what is really going to be very important is to increase the dialogue and increase better mutual understanding of requirements and tools available. I think that's going to be key, Barbara.
Thank you. Then, Jerry, maybe I go to you. So now in ACJA, in your word tag, we have published this white paper, which is talking about the LTE area profile. So the question is, now that we have the white paper, how important it is the work that is taking place, in GSMA, as you mentioned, for this work? How do you see it going forward?
Thank you for the question. GSMA has an important role in leading the mobile industry in unleashing the power of connectivity to benefit people, industry, and society, advent of 5G, and building on the success of LTE. Now, the continued growth of mobile communication services is only dependent on the availability of interoperable technologies at all levels, across all platforms and networks. Now, as a GSMA industry guideline, the LTE aerial profile will simplify UAS implementations, as well as global operator deployment and support of LTE aerial services. Now, the goal is to achieve consistent industry-wide approach, thereby promoting scale, reducing complexity, and enabling interconnect and roaming. And a lot of the innovations will come in to fulfill and realize various, business needs and requirements across a different vertical. and Eric touched on some of those. So at the end of the day, GSMA indeed, will facilitate all of this as it does today, in support of both the full member MNOs as well as the associate members, and now specific to the aviation and the drone industry, the stakeholder, companies that play in there.
Thank you, Jerry. And now we shift maybe more, let's look at a little bit of regulation. There's a lot of questions we receive also on regulations. So maybe I go first to you, Thomas Eder. And how do you see how do we ensure that the regulatory framework keep up with the pace of the technology that we have in innovation in the future? So before you answer it, please also introduce yourself, since the audience didn't hear you yet. Thank you.
Yeah, thank you very much, Barbara. Can you hear me well? Great.
Yes.
Well, my name is Thomas Eder. I'm working with Nokia Digital Automation, and together with my team, we are actually working on the dedicated task to bring the Nokia drones together with the network equipment to the field and really make sure that aerial UEs can take off in the field. So we are the team that brings the technology to the field at the moment. And therefore, I'm also super happy to join the ACJA for the future collaboration. Coming to your question, Barbara, excellent question, I must say, though not really easy to answer. I mean, ever since it's been a kind of race between regulation and innovation, no matter if we talk about autonomous vehicles, cybersecurity, and now in particular about aerial UEs or cellular connected UAVs. So first come, first serve on the one hand. If there is a regulation, then everybody needs to play according to the rules. But nevertheless, at the moment, we find ourselves in a situation where, well, not everywhere we find the right regulation in place, or it's now just being discussed, but technology is ready. So the answer would be, of course, what we are doing here right at the moment with the ACJA, which means like bringing the stakeholders together of regulation, bringing the stakeholders of aviation and mobile connectivity worlds together. That is for sure one major component, and that is, well, the regular ecosystem work among many others. So answering now in a nutshell, there are, I would say, 3 points. Collaboration across ecosystems, as we do in ACJA, a very open and honest communication of limiting factors between the regulators and the technology providers. And sometimes, even though it might hurt, trial and error to verify how difficult it is really to overcome regulatory gaps or hurdles. Yeah, thank you.
Thank you, Thomas. Now we dive even deeper in the regulations, and I go to you, Peter. And the question that I want to ask you is more related, let's say, to the US. And how do you believe it in the short or also in the long term will be the impact of the US shift in deciding to, for example, use the broadcast versus the network ID for the remote identification? Again, Peter, if you can introduce yourself first.
Sure. Hi. Thanks, Barbara, for the very easy question. My name is Peter Musgrove. I'm with AT&T and our Standards and Industry Alliances organization. And it's certainly true that cellular networking is not explicitly included in the near-term remote ID solution in the U.S. due to the FAA remote ID broadcast rule requirement using unlicensed spectrum. And certainly in the longer term, as some other folks have talked about here, it's likely that a network remote ID solution would be needed for BV loss and other applications. But it's very interesting to note that the FAA remote ID rule did not in any way prohibit the use of network remote ID in licensed spectrum. So innovations are likely to occur on cellular network remote ID license spectrum working simultaneously alongside any broadcast remote ID with the Wi-Fi or Bluetooth in the unlicensed bands. This use of the network remote ID will certainly promote the benefits of connections with UTMs or USS systems or other needed capabilities such as detect and avoid C2 and BV loss support. A cellular network remote ID solution can be pursued with the 3GPP Release 17 work that is ongoing and in the area of remote ID and tracking. Now, shifting to the near term, ACJA will certainly study how certain technologies that already exist, for example, the device-to-device proximity services, or ProSay technology that was originally developed for public safety in 3GPP, and also the PC5 silent capability originally developed for cellular V2X may be applied to support UAV remote ID via cellular broadcast mechanisms if and when FAA regulations may eventually allow such broadcast remote ID in licensed spectrum. And as an example of future cooperative standards work that can help out with this evolution, we see that the addition of both cellular broadcast technology and cellular network technology for remote ID, or perhaps via reference to the 3GPP specs, to be considered for a future revision of the ASTM F38 remote ID standard that is ongoing and very high profile. Thank you, Barbara.
Thank you, Peter. And maybe I want to go down to Thomas Neubauer to ask you, what is your view instead of the remote identification in Europe, and what it is about the network ID in Europe?
Right. Thank you. Thank you for that question, because it's a very interesting aspect that Europe has actually, different to the FAA, decided for network remote ID in U-space. So the member states have agreed to actually make network remote ID within U-space, which is part of the airspace that is defined by the member state, as a mandatory service. So that means there is actually some increased requirement for that connectivity through the network being provided. And we see that an important step for BVLOS operation, and by the regulation that has been put in place, that is becoming effective with the beginning of January 2023, so a bit more than 1.5 years ahead. We think that we'll have a overall a drive, as Peter mentioned before, for BVLOS, there will be some sort of a requirement for a network remote ID, where broadcast itself, I do not consider that sufficient. So we will have a very interesting drive towards connectivity primarily provided through cellular.
Thank you for that. And one very specific question that we also received, and I want to give it to Boris because of your expertise, is more related to how do you see the standard to be defined for the drones navigations? How will be the system managed, and what is the future plans?
So, thank you, Barbara. As I see it, there is a well-established framework for navigation for conventional aviation based on different segments. And for US, I think one of the standards is usable in more extent because, well, of the size limitations and power limitations, and that is obviously satellite-based navigation. That includes two things. First thing is a well-known set of global satellite navigation constellations, GPS, GLONASS, Galileo, and the second segment, which is more important for us, is what is called augmentation systems. Because satellite navigation systems by themselves in what is called standalone mode are not sufficient to support many operations for drones, etc. And we need to augment them to acquire proper accuracy and, which is more important, integrity, continuity, and availability. So, and using these augmentations, be it satellite-based or ground-based, posed significant challenges for many US use cases, especially in urban environments. So I would think that maybe not a near term, but in a longer term, new capabilities of cellular networks, especially 5G services, location-based location services of 5G future networks, can be used of augmentation for core constellations to perform the data fusion and to acquire precise positions with high integrity and high accuracy and well, generally high performance. That's my vision on navigation in regards to cellular networking.
Thank you, Boris. So we are running out of time. Maybe I want to have one very brief comment from you. Obviously, we didn't mention too much 5G, but how do you see maybe 5G as an intersection or working towards the 5G? What ACJA is going to do from your perspective? One very simple intervention for all of you. Maybe I start from what I see. Thomas Adder.
Well, certainly the amount of data that will be transferred now after we have successfully connected hundreds of drones across the globe will significantly increase. Somebody or something will need to process all that data. And I think that can be addressed by two major items. On the one hand, network slicing or dedicated private wireless networks in order to allocate the network resources with the utmost dedication. Or secondly, edge cloud computing in order to process all the data that gets now generated with the huge amount of drones right at the place of the origin of the data.
Chris, over to you. A brief point from you.
This question was about, just to make sure I understand, was about the scalability, I guess, of cellular over time and what ideas we need.
Yeah, maybe we don't have the time to answer completely the question, but that's why I was just looking and focusing on what it is the ACJA looking or doing in the 5G. We will fully answer the question later on, but
yeah, I think with 5G, what we see is more people coming to the network, an easier way to address them with 5G technology, but still an uncertainty of where the network provides capability. So the work we do to predict where the network can help, I think, is what ACJA is still able to do. Where can 5G support aerial, I think, is still important, even if 5G is better suited to handle those users of the network.
And I will also add that with all the different types of spectrum being used to deliver the 5G network, there's different types of capability that will be available in different places. So visibility into those capabilities geographically and altitude-wise will be pretty important. And that's some of the work that we're doing in WorkTask 2.
Hey, Barbara, real quick, just an acknowledgement that the first thing that ACJ will have to do is to make sure that we advocate for the standardization work that's still yet to take place in 3GPP in support of NR, as well as all the unique capabilities the 5G system will provide, which leads to all the different kind of vertical use, industry use of drone and further enhance innovation as such. So critical thing that we have to make sure happens, and ACJ will play an important part to that.
So unfortunately, we run out of time. We are at the top of the hour. For all of you, thank you, first of all panelists to be here and answer the question. So we still have quite a few questions that are coming, and we have received also in registration. We will answer all your questions afterwards, so don't worry. We will still reach out and respond to all your questions. So we'll take a little bit of time, but we will send all the answer to you. Again, the recording and the video and the slides will be made available. You will receive a notification by email. Please visit also our website. We have all the information there, and also all the documentations are produced by ACJA. With that, I would like to close the broadcasting. Thank you again for joining. It's been a pleasure. Thank you. See you soon. Bye.